This notebook covers grid search, random search, cross validation, learning or validation curves, and model selection strategies. It's focused on practical implementation and for your own knowledge. I will summarize each cell and call out key demo points. We import NumPy, Pandas, Matplotlib, Seaborn, and Silent Warnings. Key concepts: grid search CV, randomized search CV, k-fold and stratified k-fold CV, and hyperparameter optimization. Grid, grid search exhaustively tests exhaustively tests combos, randomized search samples, parameter space, k-fold splits data into k groups, stratified k-fold preserves class distributions. Implementation. Here, I'll walk you through reproducible code examples, synthetic data generation, CV strategy, grid or random search, and diagnostic curve. By using make classification, I have created data of 100,000 samples, 1000 samples, 20 futures, 50 informative. And by using train test split, I have divided the given data into train and test. Next, we demonstrate cross-validation strategy and show how to compute multiple metrics. Cross-validation examples: k-fold, stratified fold, multi-metrics. We know k-fold with shuffle, then stratified k-fold to maintain class proportions, both used with a random forest classifier. We compute cross-value scores and cross-validation with metrics such as accuracy, precision, recall, F1, and report mean plus or minus standard deviation. Key points: use stratified k-fold for classification to avoid skewed folds. Quick taking points: how to interpret mean or standard deviation, why multiple metrics matter, by CV consistently, we using CV consistently when comparing models. Grid search. Now we run a grid search CV example on SVC to find the best hyperparameters. We define a parameter grid for C, kernel, and gamma, then run grid search CV, where CV we have given 5 folds, n jobs as -1. After fitting, we print best parameters, best scores, and t-set scores. Also, construct a results underscore data frame to inspect top configurations. Using emphasize, grid search is thorough but expensive, useful for small parameter space or as a final fine-tune step. Here, here we can come to a conclusion which parameter should be picked to balance randomized search. Next, randomized search CV for more efficient sampling of large hyperparameter spaces. We define distributions, example randint uniform for random forest classifier hyperparameters and run randomized search CV with number of parameters as 20. It prints the best parameters and scores. Key trade-off. Randomized search explores more of space for less compute and can find strong configurations faster than grid search. Grid search when many hyperparameters are continuous or ranges are large. Key point. How to choose n enter, seed reproducibility and combining with Bayesian optimization later. Learning curve. Learning curve better. We will use learning curves to diagnose bias versus variance. Here, we call learning curve for a random forest across increasing training sizes, plot training versus validation accuracy, mean plus or minus standard deviation, and interpreted patterns. If both converge at low score, high bias, large training, validation gap, high variance. If both converge at low score, they are high bias. Large training validation gap means high variance. Use this to decide if more data, more complex model, or regularization is needed. Large train validation gap, high variance, low score, high bias. Validation curve. We run validation curve or max step for a random forest over range of 1 to 20. Plotting training validation scores and look for where validation is maximized without overfitting. We have to find a sweet spot for a parameter and to detect when increasing complexity, where when increasing complexity stops helping. Combined with strong curves for stronger diagnostics. Best practices. Split before pre-processing. Always use cross-validation for model comparison. Monitor overfitting versus underfitting. Document hyperparameters or experiments. Start simple, then add complexity. Also mention using pipeline or column transformers to avoid leakage and ensure reproducibility. Common questions. Here, in these questions, we will understand how to implement algorithms, compare methods, tune systematically, and apply to real dataset. Here, what resources which we have used? We have used such as scikit-learn docs, TensorFlow or PyTorch tutorials, and suggested access. and you can practice it. Practice other exercises. What are the main concepts in model selection and hyperparameter tuning? Grid search, random search, and cross validation. So, when to use what? Apply when you need to improve model performance, reduce dimensionality, or extract meaningful parameters from data. What are the challenges? Common challenges are overfitting, computational complexity, hyperparameter tuning, and interpretation of results. These are the additional practice exercises.